Hey, Dr. B here, and let's talk about energy and water. In our last lesson, we mentioned that it's really hard to heat up water. It requires 4.184 joules per gram per degree Celsius, which places it just about on the absolute top of all substances known in terms of its resistance to a temperature change. In this lesson, we're going to apply that to go from ice to steam. We'll be asking ourselves how many nutritional calories are required to take 18 grams, I chose that on purpose, that happens to be a mole, of water, and take it from minus 20 all the way up to 110 degrees Celsius. We'll have to consider phase changes, we'll have to consider different phases of water, and add them all up. So, we have not only to heat water up, but we have to undergo the phase changes. We call those the standard enthalpies of vaporization and fusion. It's another example of scientists giving fairly complex terms for, fairly simple processes. The enthalpy of vaporization of water is how much energy is required to turn it from a liquid to a gas. Now, you might not think that that's that hard to do, but 2,260 joules per gram? Oh my God, that's a big number. And you're not talking about just boiling the water. You're talking about boiling it to dryness, completely changing the phase. You can boil water, but imagine leaving it on the pot until it is gone, right? That's why that's such a big number. Vaporization is a decent term. The enthalpy of fusion of water is much lower. That means to melt it, to take all that solid water, that ice, and turn it into liquid water. It takes 334 joules per gram. I have no idea why they chose the word fusion if you're liquefying. It seems like the opposite, but that's the one they came up with. Perhaps they were actually freezing it, and because it's equal and opposite. Perhaps they, but they're not, anyhow, that's the term they use. Okay, so that's what we have to do. We have to take that block of ice, melt it, bring it up to its boiling point, and boil it completely. So we've got processes going on. There's the melting, there's the boiling. If you're going in the opposite direction, we would call it the condensation, right? That would be going from the gas to the liquid, equal and opposite. And this we'd simply call the solidification. I'd call it freezing. It's minus 334 joules per gram. Note that means that as you're taking steam and bringing it down to solid ice, these are heat releasing processes. These release heat to the surroundings. Okay, so let's do it. Let's take that cup of water and let's consider the, it must be about 5 steps that are involved, right? First, you got that block of ice. Can it be below 0 degrees Celsius? Sometimes I get students who are like, no, it's ice is at 0 degrees Celsius. Well, if you'd spent some time up in, I don't know, Portland, Maine, you'd say, I don't think so. Ice can keep getting colder, and it can. It can get down way below 0 degrees Celsius. So first you got to heat it up to its melting point. That would be a Q equals MC delta T situation. Then you got to melt it. That takes 334 joules per gram. Then you got to take that 0 degree water, bring it up to 100 degrees Celsius. That's a Q equals MC delta T. You then have to take that water that's at 100 degrees, starts to bubble, right? And you have to vaporize it completely to 100 degree at 100 degrees, and then you have to heat up the steam. And you have to heat up the steam another 10 degrees in this case. So let's add them all up. Heats from minus 20 to 0 degrees Celsius. It's not a phase change, so Q equals MC delta T, but be careful which C you choose. These are all 3 for water. We're dealing with ice, so there's the value there. Mass, 18 grams. Specific heat, 2.03 joules per gram degree Celsius. Temperature change, 20 degrees. Plug it in, somebody does it for you. Wonderful. Now it's at its 0 degrees, you're going to phase change it. It takes 334 joules for each gram. We got 18 grams. Units cancel nicely. Grams is gone. We get joules. Now we got to heat up that liquid water 100 degrees. You might think that's the big energy component. Well, it's liquid water, so I like that number. It's still 18 grams. We got to go the whole 100 degrees. I should have the units there, but I got lazy. Yeah, it's the biggest one so far, 7,524 joules to do that. Now it's at 100 degrees, and we got to do the phase change. This takes 2,260 joules for each gram, and there's 18 grams. Check out this number. 40,000 joules. By far the most major component. It's not hard to get water to boil. It's hard to remove water as a gas as it's boiling. That takes a while. And finally, another 20 degrees. Q equals mc delta T. I think here we better use the steam numbers. Finally, we got all 1, 2, 3, 4, 5 numbers. Plug them in. It's, what is that? 58,000 plus joules. I like to compare that to nutritional calories because I just don't really have a feeling. If I know joules are tiny, I don't know if that's a lot or a little. Change it to nutritional calories. There's 4,184 joules in a nutritional calorie, and we're only talking about 14 nutritional calories. I suppose if I was really talking about money, I'd compare it to kilowatt hours, because I know it takes 10 cents per kilowatt hours, and I'd be worried, you know, being a dad and everything, I'd be worried about how much energy it takes to make stuff using my stove or whatever. So 14 nutritional calories, that's not much. What is that, a potato chip or two? This is an introduction to energy and water.